Hi, sixth graders, and welcome to our very first day of Unit 9. In our last unit, we looked at how to find the area of really complex shapes, both inside and outside of the coordinate grid. And in this unit, we are taking that to the next level by looking at three-dimensional objects and learning how to find the surface area and the volume of them. This is a really exciting geometry unit because we are building on the work we did in 5th grade where we looked at the volume of three-dimensional shapes. And some of the shapes that we are going to look at today should look familiar from your work in 5th grade. Today we're going to be taking our 3D shapes and actually making them two-dimensional by looking at something that are called nets. Before we dive into the content, please remember you will need your classwork open as well as a pencil and paper. Please make sure you are also in a distraction-free zone. And with that, let's dive in. The first shape we are going to be looking at together should look familiar from 5th grade. Raise a virtual hand in Zoom if you know what the name of this shape is. Pause the video and your teacher will call on one scholar who has their hand raised to see if they can name this shape. If you said that this is a rectangular prism, you are right. Any 3D shape has 3 dimensions: length, width, and height. And you know from your work in volume how to measure the length, width, and height of this shape. Now, this is called a rectangular prism because all of the faces on this shape are rectangles. This also has 2 bases. We see the base on our bottom, and there's a parallel base on the top. In case you're having trouble visualizing the shape in 3 dimensions, I also have a piece here. As you can see, this is just like what you see on your page, and it is a rectangular prism. Now, this has rectangular faces, meaning all of the sides of this shape are rectangles, and it has 2 bases. So what happens if we actually take this 3-dimensional shape and make it 2-dimensional? We can do that by taking my 3-dimensional shape here and actually folding down all of the sides. And then I get this flat shape made of my rectangular faces. This is called a net. And as you can see here, it has the exact same faces that my 3-dimensional shape had. And you can see that I labeled my 2 bases, which are parallel. They're also the same size. If I were to fold this back up again, I would be able to recreate my 3-dimensional rectangular prism, although I could use some tape to hold it together. When I unfold it again, I see my net. That brings us to our first important definition today that you need to write into your classwork. A net is a flat shape that can be folded into a solid. Pause the video now and write this definition into your Google classwork. As I said, this is a rectangular prism because it has 2 bases. Anytime we see the word prism to classify a shape, we know that it has 2 parallel bases. Here are some more examples of prisms. As you can see here, we have our rectangular prism with our 2 parallel bases. This is a cube where all of the faces are actually square, and we see our 2 parallel bases. And over in the top right corner, you can see a triangular prism. This has 2 parallel bases that are triangles. That's why it's called a triangular prism. Prisms have 2 bases that are parallel. Pause the video now and write that in your Google classwork. Now we'll see a lot of prisms with 2 parallel bases. We are also going to be working with pyramids. As you can see here, the difference between a prism and a pyramid is that a pyramid only has 1 base and a vertex that is perpendicular. You can see here that the base on the pyramid on the left is a square, and the base on the pyramid on the right is a triangle. There is only 1 base in a pyramid. Pause the video and write this definition in your Google classwork. Now we're going to take a look at 2 shapes that sound very similar but are very different. On the left, we have a shape, and on the right, we have a shape. Notice that the base of both of these shapes is a rectangle. So what is the key difference between these shapes? The key difference is that on the left, we call this a rectangular pyramid because it only has one rectangular base. The shape on the right we're very familiar with is a rectangular prism because it has two rectangular bases. The names sound very similar, but they are very different. So remember, when you only see one base, that is a pyramid. When you see two parallel bases, that is a prism. And that brings us to our next fence post for today, which is that we name 3D figures based on the shape and the number of bases. So, as we saw here, the base in both of these was a rectangle. That's why both shape names start with rectangular. But their number of bases are different. That's why the first one is a rectangular pyramid, while the second one is a rectangular prism. Putting everything we just went through together, we arrive at our key point for today. It says, a net of a 3D figure can be determined using the shape's attributes. As we saw in this net that I created, all of the bases are rectangular. That's why this name starts with the word rectangular. And we saw that when I create this into a 3D figure, it has two bases. That's why this is called a rectangular prism. Pause the video and type your key point into your Google classwork. Now let's look through one more problem together. It might be a little hard to visualize this, so I'm going to show you how I made this shape in 3D. This is what this shape looks like in 3D. Now my question for you is, based on what we just learned, what is the name of this shape? Is this a triangular prism or a triangular pyramid? If you think it's a triangular prism, when I say go, you'll hold a 1 up so that your teacher can see it in your video. If you think it's a triangular pyramid, you'll hold a 2 up so that your teacher can see it in your video. Ready? Go. If you said that this was a triangular pyramid, you were correct. The reason why this is a triangular pyramid is because it only has one base. Now we are going to talk about how we could actually take this 3-dimensional shape and create a 2-dimensional net. Remember, our net can be folded into a 3-dimensional shape. So if I have my 3D shape here, the way I'm going to visualize my net is by folding down all of my sides until I get a shape that looks like this. This is my triangular base, and these are my other faces of my shape. So let's talk about what that actually looks like on paper. As you can see here, when I unfolded my triangular pyramid, I got this net. Pause the video now and sketch this net on your paper. Now, just drawing the net is not enough because we were actually given dimensions in our 3D shape. So I first am going to look at the base, which is my middle base on my net, and it's the bottom of my 3-dimensional figure. I see that blue line 6 points to the top of my base, so I can label that as 6. I notice also that 5 inches are the other 2 sides of my base. So I label my base with the side lengths 6, 5, and 5. Make sure you have this down on your paper in the next 10 seconds. Now it's your turn. Using what you see on the left, take the next minute on your own, on your paper, to label all of the sides of your net. Then we'll come back together and you'll be able to compare your work with mine to see if you were able to label all sides correctly. Go. Check your work with mine. This is a little tricky to see, but again, you need to remember that you're folding down the sides of the triangular pyramid so that it's flat. Take the next 15 seconds to update your work to make sure you have the correct dimensions on your paper. In today's classwork, please keep the following CFS in mind. Make sure you annotate your problem with margin notes to provide additional meaning. That will include number of bases and what the name of a shape that you're looking at is. Next, make sure you draw your net clearly and accurately. Lastly, label all dimensions if they are provided, like we just did in the problem together. Today's work is a little bit tricky because it can be really hard to visualize these 3D images, but I know you guys are up for the challenge. So as you're sketching your net, really use your imagination and your creativity to actually imagine the 3D figure folding down onto a flat surface like I showed you in this video. Thank you all for your focus today, and I am excited to continue the rest of Unit 9 with you all.